An induction motor can utilize two main types of rotors: squirrel cage rotors and wound rotors. Squirrel cage rotors are more common due to their simple construction, reliability, and lower cost. They consist of conductive bars, typically aluminum or copper, embedded in slots around the rotor core and shorted at both ends by end rings. Wound rotors, on the other hand, have insulated windings connected to slip rings. These slip rings allow external resistors to be connected in series with the rotor winding, providing control over the motor's speed and torque characteristics, especially during startup. Now let's talk about hybrid systems, focusing on identifying non-hybrid components from the given options. Hybrid systems combine multiple energy sources to provide a more reliable and efficient power supply. Common examples include combinations of batteries, wind turbines, and photovoltaic, that is PV, systems. Micro-hydro generators, while a source of renewable energy, do not inherently constitute a hybrid system unless combined with another energy source like those previously mentioned. Therefore, micro-hydro generators are classified as a standalone energy source rather than a component of a hybrid system by default. FPLP cable, which stands for Firepower Limited Power Plenum Cable, is designed for specific applications based on its fire resistance and low smoke characteristics. The question indicates that FPLP is suitable for a damp location. However, the answer is technically incorrect in the context of typical cable selection guides. While it can be used in dry locations, FPLP is specifically designed and rated for use in plenum spaces. Plenum spaces are areas within buildings used for air circulation, such as above suspended ceilings or under raised floors. These areas require special cable that produces minimal smoke and flame in the event of a fire to prevent the spread of toxic fumes throughout the building. Standard cable types may release hazardous fumes and propagate flames rapidly, making them unsuitable for plenum use. If the question meant to ask where FPLP cable is technically rated, the correct answer would be plenum locations. Lastly, let's define the role of UL under Rotors Laboratories. UL is an independent, non-profit organization that focuses on product safety testing and certification. It develops standards and procedures for evaluating products, components, materials, and systems. When a product is UL listed, it means that UL has tested a sample of the product and determined that it meets UL's requirements for safety and performance based on published standards. UL certification covers a wide range of product categories, including electrical appliances, fire protection equipment, and building materials. UL does not manufacture, install, or maintain any products. Its primary function is to independently verify the safety and performance claims made by manufacturers. Achieving UL listing or certification demonstrates that a product has undergone rigorous testing and meets established safety standards, providing confidence to consumers, regulators, and other stakeholders. To further clarify the characteristics of induction motor rotors, let's delve into their design and functionality. Squirrel cage rotors, the workhorses of induction motors, are known for their simplicity and robustness. Their construction involves embedding conductive bars, usually made of aluminum or copper, into slots on the rotor core. These bars are then shorted together at both ends by end rings, forming a closed electrical circuit. The absence of external connections or windings makes squirrel cage rotors maintenance-free and highly reliable. When the motor is energized, the rotating magnetic field produced by the stator induces a current in the rotor bars. This current creates its own magnetic field, which interacts with the stator field, generating torque and causing the rotor to rotate. The speed of the rotor is slightly less than the synchronous speed of the stator field, resulting in what is known as slip. This slip is necessary for inducing current in the rotor and producing torque. Wound rotors, on the other hand, offer greater flexibility in terms of speed and torque control. Unlike squirrel cage rotors, wound rotors have insulated windings that are connected to slip rings. These slip rings allow external resistors to be connected in series with the rotor winding. By varying the resistance in the rotor circuit, the motor's speed and torque characteristics can be adjusted. Adding resistance increases the rotor's impedance, which reduces the starting current and increases the starting torque. This is particularly useful for applications that require high starting torque, such as cranes and elevators. As the motor accelerates, the external resistance can be gradually reduced to improve efficiency and operating speed. Wound rotor motors are more complex and expensive than square cage motors, and they require regular maintenance of the slip rings and brushes. Now, expanding on the concept of hybrid systems, it's essential to understand the advantages they offer in terms of reliability and sustainability. Hybrid systems combine multiple energy sources to provide a more consistent and dependable power supply. For example, a hybrid system might integrate solar panels, wind turbines, and battery storage. During sunny and windy conditions, the solar panels and wind turbines generate electricity, which can be used to power loads or charge the batteries. When the sun isn't shining or the wind isn't blowing, the batteries can discharge to provide electricity. The combination of multiple energy sources reduces the system's reliance on any single source and ensures a more stable power supply. Battery storage is a key component of many hybrid systems. Batteries can store excess energy generated by renewable sources and release it when needed. This helps to smooth out fluctuations in energy production and ensure a continuous power supply. Hybrid systems can also be connected to the grid, allowing them to draw power from the grid when renewable sources are unavailable or when demand exceeds supply. This further enhances the system's reliability and stability. Microhydro generators, while a valuable source of renewable energy, are not inherently part of a hybrid system unless they are combined with another energy source. Microhydro generators harness the energy of flowing water to generate electricity. They are typically used in small-scale applications, such as powering homes or businesses in remote areas. While microhydro generators can provide a reliable source of electricity, their output can vary depending on water flow conditions. Therefore, they are often combined with other energy sources, such as solar panels or batteries, to create a hybrid system. Going into more detail about the selection and application of FPLP cable, it's important to understand its specific properties and limitations. FPLP cable is designed for use in plenum spaces, which are areas within buildings used for air circulation. These areas include above suspended ceilings, under raised floors, and within air ducts. Plenum spaces require special cable that produces minimal smoke and flame in the event of a fire. This is because smoke and toxic fumes can spread rapidly through the air circulation system, endangering occupants throughout the building. FPLP cable is constructed with materials that are specifically designed to resist flame propagation and produce low levels of smoke. The cable jacket is typically made of a fire-retardant material, such as Teflon or polyvinyl chloride PVC, that is treated with fire-retardant additives. The conductors are also insulated with materials that are resistant to heat and flame. FPLP cable is tested and certified to meet specific fire safety standards such as those established by UL. These standards specify the maximum allowable flame spread, smoke density, and toxicity levels for cable used in plenum spaces. Using the correct type of cable in plenum spaces is essential for protecting occupants and preventing the spread of fire. While FPLP cable can be used in dry locations, it is not typically required unless the cable is installed in a plenum space. In damp or wet locations, other types of cable, such as those with moisture-resistant insulation, may be more suitable. Finally, let's explore the detailed functions and services provided by UL. UL is a global safety science organization that provides a wide range of services, including testing, inspection, certification, auditing, and validation. Its mission is to promote safe living and working environments by applying scientific expertise to address safety, security, and sustainability challenges. UL develops and publishes standards for a wide variety of products, components, materials, and systems. These standards are based on scientific research, engineering expertise, and industry best practices. They cover a wide range of safety aspects, including electrical safety, fire safety, mechanical safety, and environmental safety. UL. Test products to determine whether they comply with its standards. Products that pass UL's testing requirements are eligible to bear the UL mark, which is a widely recognized symbol of safety and quality. The UL mark indicates that a sample of the product has been tested and found to meet UL's requirements for safety and performance. UL also provides inspection services to manufacturers to ensure that their products are consistently manufactured to meet UL's standards. UL's inspectors visit manufacturing facilities to review production processes, quality control procedures, and documentation. UL's certification services go beyond simply testing products to determine whether they comply with its standards. UL also provides ongoing surveillance to ensure that certified products continue to meet UL's requirements over time. This includes periodic testing of products and audits of manufacturing facilities. UL's auditing services help organizations to assess and improve their safety, security, and sustainability performance. UL's auditors conduct on-site assessments to evaluate an organization's policies, procedures, and practices. They then provide recommendations for improvement. UL's validation services provide independent verification of claims made by manufacturers about their products. This can include verifying the accuracy of product performance claims, validating the environmental impact of products, and confirming the safety of products. UL's services are used by a wide range of organizations, including manufacturers, retailers, government agencies, and consumers. UL's expertise and reputation for independence and integrity make it a trusted source of safety information. The organization's work helps to protect people, property, and the environment from harm. Furthermore, let's analyze the specifics of square cage rotor construction and how it contributes to its performance. The conductive bars in a square cage rotor are typically made of aluminum or copper, chosen for their high electrical conductivity. These bars are inserted into slots that are evenly distributed around the rotor's circumference. The slots are designed to optimize the motor's performance characteristics such as starting torque, speed, and efficiency. The bars are not insulated from the rotor core, which is typically made of laminated steel. This allows current to flow freely between the bars and the core, creating a closed electrical circuit. The end rings, which short the bars together at both ends, are also made of conductive material, usually aluminum or copper. The end rings are designed to minimize resistance and ensure uniform current distribution among the bars. The square cage rotor's simple and robust construction makes it highly reliable and resistant to damage. It can withstand high temperatures, vibration, and other harsh operating conditions. The absence of external connections or windings eliminates the need for brushes and slip rings, reducing maintenance requirements and improving overall reliability. Now, let's examine the benefits and drawbacks of wound rotor motors compared to square cage motors. Wound rotor motors offer several advantages over square cage motors, including higher starting torque, lower starting current, and adjustable speed control. The ability to add external resistance to the rotor circuit allows for precise control over the motor's torque and speed characteristics. This makes wound rotor motors suitable for applications that require high starting torque or adjustable speed, such as cranes, elevators, and conveyors. However, wound rotor motors also have some disadvantages compared to square cage motors. They are more complex and expensive to manufacture, and they require regular maintenance of the slip rings and brushes. The external resistors also dissipate energy, which can reduce the motor's overall efficiency. In contrast, square cage motors are simpler, less expensive, and require less maintenance. They are also more efficient than wound rotor motors under normal operating conditions. For applications that do not require high starting torque or adjustable speed, square cage motors are generally the preferred choice. Expanding on hybrid systems and the role of batteries, it's important to consider the different types of batteries used in these systems. Lead-acid batteries are the most common type of battery used in hybrid systems due to their low cost and readily available technology. However, lead-acid batteries have a limited lifespan and require regular maintenance. Lithium-ion batteries are becoming increasingly popular in hybrid systems due to their higher energy density, longer lifespan, and lower maintenance requirements. However, lithium-ion batteries are more expensive than lead-acid batteries. Other types of batteries, such as nickel metal hydride and flow batteries, are also used in hybrid systems, but they are less common than lead-acid and lithium-ion batteries. The choice of battery type depends on the specific requirements of the hybrid system, such as cost, performance, lifespan, and maintenance. Batteries play a crucial role in hybrid systems by storing excess energy and releasing it when needed. This helps to smooth out fluctuations in energy production and ensure a continuous power supply. Batteries can also provide backup power in the event of a grid outage. In addition to batteries, other energy storage technologies such as flywheels, supercapacitors, and pumped hydro storage can also be used in hybrid systems. These technologies offer different advantages and disadvantages in terms of energy storage capacity, response time, and lifespan. Discussing the nuances of FPLP cable and its fire safety characteristics, it's important to understand the testing procedures used to evaluate its performance. FPLP cable is subjected to a variety of fire tests to ensure that it meets the requirements of applicable standards. These tests include flame spread tests, smoke density tests, and toxicity tests. Flame spread tests measure how quickly a flame propagates along the cable. The cable is exposed to a controlled flame, and the distance the flame travels along the cable is measured over a specific period of time. The flame spread rating is an indicator of how likely the cable is to contribute to the spread of a fire. Smoke density tests measure the amount of smoke produced by the cable when it is burned. The cable is burned in a controlled environment, and the density of the smoke is measured using a light beam. The smoke density rating is an indicator of how much the cable will obscure visibility in the event of a fire. Toxicity tests measure the toxicity of the gases released by the cable when it is burned. The cable is burned in a controlled environment, and the gases are analyzed to determine their toxicity. The toxicity rating is an indicator of how harmful the cable's combustion products are to humans. FPLP cable must meet stringent requirements for flame spread, smoke density, and toxicity to be certified for use in plenum spaces. These requirements are designed to minimize the risk of fire, smoke inhalation, and toxic gas exposure in the event of a fire. Lastly, going into the depth of UL's standard development process, it's important to recognize the stakeholders involved and the rigor applied. UL standards are developed through a consensus-based process that involves a wide range of stakeholders, including manufacturers, consumers, government agencies, and industry experts. This process ensures that UL standards are technically sound, reflect the needs of all stakeholders, and are updated regularly to keep pace with technological advancements. The development of a UL standard typically begins with a proposal from a stakeholder. The proposal is reviewed by a UL standards technical panel, which is composed of experts in the relevant field. The technical panel may conduct research, gather data, and solicit feedback from other stakeholders before making a decision on the proposal. If the technical panel approves the proposal, it is then published for public comment. The public comment period allows interested parties to review the proposed standard and provide feedback. The technical panel considers all comments received and makes revisions to the proposed standard as necessary. Once the technical panel is satisfied with the proposed standard, it is submitted to the UL Standards Council for approval. The UL Standards Council is responsible for ensuring that UL standards are developed in accordance with UL's policies and procedures. If the UL Standards Council approves the proposed standard, it is then published as a UL standard. UL Standards are updated regularly to reflect technological advancements and address new safety concerns. The UL standards development process is designed to be transparent, open, and inclusive. This ensures that UL standards are technically sound, reflect the needs of all stakeholders, and are updated regularly to keep pace with technological advancements. Now delving into induction motor theory, the principle of operation relies on electromagnetic induction. The stator windings, when energized with alternating current, produce a rotating magnetic field. This rotating field sweeps across the rotor conductors, inducing a voltage in them according to Faraday's law of electromagnetic induction. Since the rotor conductors form a closed circuit, the induced voltage causes a current to flow through them. This current, in turn, generates its own magnetic field around the rotor conductors. The interaction between the stator's rotating magnetic field and the rotor's magnetic field produces a torque on the rotor, causing it to rotate. The direction of the torque is such that it opposes the relative motion between the stator field and the rotor conductors, as dictated by Lenz's law. The rotor speed never quite reaches the synchronized speed of the stator field. This difference in speed, known as slip, is essential for the induction process to occur. If the rotor were to rotate at the same speed as the stator field, there would be no relative motion between them, and no voltage would be induced in the rotor conductors. Therefore, the induction motor is inherently a slip-dependent machine. The amount of slip is proportional to the load in the motor. As the load increases, the rotor slows down, increasing the slip and the induced voltage in the rotor conductors. This results in a higher rotor current and a greater torque to meet the increased load demand. Let's consider practical aspects of hybrid system design, focusing on component sizing and optimization. A well-designed hybrid system should be able to meet the load demand reliably and efficiently, while minimizing the cost of the system. Component sizing is a critical aspect of hybrid system design. The size of the solar panels, wind turbines, batteries, and other components must be carefully selected to match the load demand and the available renewable resources. The load demand is the amount of electricity that the system needs to supply. It is typically expressed in terms of kilowatt-hours per day or kilowatt-hours per year. The available renewable resources are the amount of solar energy, wind energy, or other renewable energy sources that are available at the site. The amount of solar energy is typically expressed in terms of kilowatt-hours per square meter per day. The amount of wind energy is typically expressed in terms of meters per second. The component sizing process involves analyzing the load demand and the available renewable resources to determine the optimal size of each component. This can be done using computer simulation software or by hand calculations. In addition to component sizing, optimization is also an important aspect of hybrid system design. Optimization involves adjusting the system's operating parameters to maximize its performance. This can include adjusting the charging and discharging rates of the batteries, controlling the output of the solar panels and wind turbines, and managing the flow of power between the different components. Optimization can be done using control algorithms or by manual adjustments. The goal of optimization is to maximize the system's efficiency, reliability, and cost-effectiveness. Now let's consider the broader implications of cable selection in electrical installations beyond just FPLP for plenums. The selection of the correct type of cable for an electrical installation is critical for safety and performance. The cable must be able to carry the required current without overheating, and it must be able to withstand the environmental conditions to which it will be exposed. There are many different types of cable available, each with its own unique properties and applications. Some common types of cable include THHN, THWN, OFF, and MC cable. THHN and THWN cable are commonly used for general-purpose wiring in dry and wet locations, respectively. UF cable is designed for underground installations, and MC cable is a metal-clad cable that provides mechanical protection. The National Electrical Code, or NEC, provides detailed requirements for cable selection and installation. The NEC specifies the types of cable that are permitted for use in different applications, as well as the ampacity, or current carrying capacity, of different cable sizes. The NEC also provides requirements for cable installation, such as the minimum bending radius and the maximum spacing between supports. Compliance with the NEC is essential for ensuring the safety and reliability of electrical installations. Incorrect cable selection or installation can lead to overheating, electrical shock, and fire hazards. We now turn our attention to the ongoing vigilance that UL maintains over certified products through surveillance programs. UL's commitment to safety doesn't end once a product is certified. To ensure that certified products continue to meet UL's requirements over time, UL conducts regular surveillance audits of manufacturing facilities and performs periodic testing of products. The surveillance audits involve inspectors visiting manufacturing facilities to review production processes, quality control procedures, and documentation. The inspectors verify that the manufacturer is using the same materials and processes that we used when the product was originally certified. They also check for any changes in the design or construction of the product. The periodic testing involves UL engineers selecting samples of certified products from the market and testing them to ensure that they still meet UL's requirements. The testing may include electrical safety tests, fire safety tests, mechanical safety tests, and environmental safety tests. If a UL surveillance audit or periodic test reveals that a certified product no longer meets UL's requirements, UL may take action to address the issue. This could include requiring the manufacturer to make changes to the product, suspending the product certification, or withdrawing the product's UL listing. UL's surveillance program is an important part of its commitment to safety. It helps to ensure that certified products continue to meet UL's requirements over time, protecting consumers from potentially unsafe products. In considering the practical applications of induction motors, it is important to understand their torque speed characteristics. The torque speed curve of an induction motor provides valuable information about its performance capabilities. At standstill, the motor produces its maximum torque, known as the starting torque. As the motor accelerates, the torque typically decreases until it reaches a minimum value, known as the pull-up torque. As the motor continues to accelerate, the torque increases again until it reaches a maximum value, known as the breakdown torque. Beyond the breakdown torque, the torque decreases rapidly as the motor approaches its synchronous speed. The shape of the torque speed curve depends on the design of the motor, particularly the rotor resistance. Motors with high rotor resistance have higher starting torque and low breakdown torque, while motors with low rotor resistance have lower starting torque and higher breakdown torque. The torque speed curve is an important factor in selecting the appropriate motor for a particular application. For applications that require high starting torque, such as cranes and elevators, a motor with a high starting torque is necessary. For applications that require high operating efficiency, such as pumps and fans, a motor with a high breakdown torque is preferred. Delving further into hybrid system control strategies, consider the energy management system and its functions. The energy management system, or EMS, is the brain of a hybrid system. It monitors the various components of the system, such as the solar panels, wind turbines, batteries, and load, and makes decisions about how to operate the system to meet the load demand while maximizing efficiency and minimizing costs. The EMS uses a variety of control algorithms to manage the flow of power between the different components of the system. These algorithms may be based on factors such as the availability of renewable resources, the state of charge of the batteries, and the load demand. The EMS can also be used to optimize the system's performance by adjusting the charging and discharging rates of the batteries, controlling the output of the solar panels and wind turbines, and managing the flow of power between the different components. In addition to controlling the system's operation, the EMS can also be used to monitor the system's performance. The EMS can track the amount of energy produced by the solar panels and wind turbines, the amount of energy stored in the batteries, and the amount of energy consumed by the load. This information can be used to identify problems with the system and to optimize its performance over time. The MS is an essential component of any hybrid system. It ensures that the system operates efficiently, reliably, and cost-effectively. Let's now examine the practical considerations for cable installation, focusing on ampacity, directing, and correction factors. The ampacity of a cable is the maximum amount of current that it can carry without overheating. The ampacity of a cable is determined by its size, insulation type, and installation conditions. The NEC provides tables that list the ampacities of different cable sizes and insulation types under various conditions. However, the ampacity of a cable may need to be derated or corrected based on the specific installation conditions. Derating factors are applied when the cable is installed in conditions that reduce its ability to dissipate heat. These conditions may include high ambient temperatures, multiple cables bundled together, or cables installed in conduit. Correction factors are applied when the cable is installed in conditions that improve its ability to dissipate heat. These conditions may include low ambient temperatures or cables installed in free air. The NEC provides tables that list the derating and correction factors for different installation conditions. It is important to apply the appropriate derating and correction factors to ensure that the cable is not overloaded. Overloading a cable can cause it to overheat, which can lead to insulation damage, electrical shock, and fire hazards. Finally, consider the global landscape of safety standards and how UL interacts with other international organizations. UL is a global organization that works with other international standards organizations to promote safety and harmonization of standards. UL participates in the development of international standards such as those developed by the International Electrotechnical Commission, or IEC, and the International Organization for Standardization, or ISO. UL also works with other standards organizations to harmonize its standards with international standards. This helps to reduce barriers to trade and to ensure that products that are certified by UL meet the safety requirements of different countries. UL's global presence and its commitment to safety make it a trusted source of safety information around the world.